Let's clear something up first. PhD students don't research better because they're smarter. They research better because they approach information differently. Most people research like they're collecting answers. PhD students research like they're mapping a landscape. And that single difference changes everything. Because research isn't about how much you read. It's about how you orient yourself before, during, and after reading. Why most research feels confusing. When most people research a topic, they follow a familiar pattern. They open Google, they type a question, they click a few links, they read until they feel informed. That feeling is dangerous, because what you're actually building isn't understanding. It's familiarity without structure. You've seen facts, terms, and explanations, but you don't know how they connect. You don't know what's foundational and what's optional, and you wouldn't know what to explain if someone challenged your understanding. This is exactly what academic researchers are trained to avoid. Step 1. Study the question before the topic. Here's something PhD students do that almost no one else does. They don't begin by asking, "What do I need to know?" They begin by asking, "What kind of question am I dealing with?" Because different questions require different kinds of thinking. Some questions are definitions, cause and effect problems, comparisons, mechanism explanations, ongoing debates. For example, what is dopamine? How does dopamine influence motivation? Is dopamine the main driver of motivation? Those look similar, but academically they are completely different questions. Before reading anything, researchers write down, "What exactly am I trying to explain?" This step is not optional in serious research. It's how you prevent shallow reading later. Step 2. Map the terrain before you dive in. PhD students skim strategically before reading deeply, not to memorize, not to understand every detail, just to answer one question. What are the major pieces of this topic? They scan introductions and conclusions, abstracts, headings and subheadings, review articles. In academic research, this is called surveying the literature. At this stage, details don't matter yet. You're building a mental outline, major themes, recurring concepts, dominant perspectives, points of disagreement. Think of it like looking at a city map before walking the streets. Without the map, every fact feels random. With it, facts know where they belong. Step 3. Use academic search logic, not just keywords. Serious research doesn't rely on one Google search. Researchers think in concept clusters. Instead of searching one phrase, they look for synonyms, related theories, technical terms, alternative framings. For example, researching motivation might lead you to self-determination theory, intrinsic versus extrinsic motivation, effort-based decision-making, reward prediction error. This is why academic databases work so well. They're built around concept relationships, not surface keywords. Better search logic means fewer irrelevant sources, higher quality material, less wasted time. Step 4. Read backward through citations. Most people read what's written. PhD students read where ideas came from. When they encounter a strong claim, they ask, "What study supports this? Is this original evidence or interpretation? How old is this finding? Who else is citing this work?" They follow citations backward. This is how researchers find foundational studies, influential authors, key debates in the field. When the same names and studies keep appearing, you've reached the core of the literature. This is how depth forms without endless reading. Step 5. Read actively, not passively. PhD students are not passive readers. They don't read to agree or disagree immediately. They read to interrogate the argument. While reading, they ask, "What is being assumed here? What's being simplified? What evidence supports this claim? What would a critic say?" This habit is central to academic training. Understanding becomes strong not when ideas feel comfortable, but when you can explain where they work and where they break. That's real comprehension. Step 6. Write to think, not to store information. Here's a misconception most people have. Notes are not for saving information. They're for clarifying thought. PhD students don't copy large blocks of text. They write short interpretations in their own words. Instead of "dopamine increases motivation," they write, "This study argues dopamine affects willingness to exert effort, not pleasure itself," a key distinction. Writing exposes gaps in understanding immediately. If you can't explain an idea simply, you don't understand it yet. And that's not failure, that's feedback. Step 7. Look for tension, not completion. Most people research until they feel finished. PhD students research until they find tension. They look for contradictions, disagreements, unanswered questions, limits in existing evidence. In academia, these tensions are where new research comes from. If everyone agrees on something, it's usually surface level. Depth lives where intelligent people disagree for good reasons. When you can explain why two strong sources disagree, what each side gets right, and where the evidence is weak, you've reached PhD-level understanding, without needing a PhD. Step 8. Rebuild the idea from memory. Periodically, researchers stop reading and ask, if I had to explain this right now, what would I say? Not perfectly, not confidently, just honestly. This step forces synthesis. Gaps appear. False confidence disappears. Understanding becomes usable. Research is complete not when you've read enough, but when you can reconstruct the idea in your own structure. Why this approach feels slower but isn't. At first, this approach feels inefficient. You read less, you pause more, you question constantly. But something changes. You stop rereading, you stop forgetting, you stop feeling lost. Understanding compounds. That's why PhD students don't know everything. They know how to build understanding efficiently. The real shift. Research like a PhD student isn't about intelligence. It's about asking better questions, building structure early, reading actively, writing to clarify, and accepting uncertainty. Once you stop collecting information and start constructing understanding, research becomes calm, controlled, and powerful. And that's when deep learning actually happens.